The concept of the multiverse is a fascinating and complex topic that has intrigued scientists and philosophers alike for centuries. The idea that there could be multiple universes, each with its own set of physical laws and properties, challenges our traditional understanding of the cosmos. In this chapter, we will explore the various theories and implications of the multiverse hypothesis. One of the most well-known theories is the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of a quantum event actually occurs in a separate universe. This leads to the existence of an infinite number of parallel worlds, each branching off from our own reality. Another theory is the bubble multiverse, where universes exist as separate bubbles within a larger multiverse ocean. These bubbles can collide or merge, leading to potentially observable effects in our own universe. The concept of the multiverse raises profound questions about the nature of reality, the existence of other intelligent life forms, and the ultimate fate of the cosmos. As scientists continue to explore the frontiers of physics and cosmology, the multiverse remains a tantalizing possibility that could revolutionize our understanding of the universe. By delving into the scientific and philosophical aspects of the multiverse, we hope to gain a deeper appreciation for the complexity and beauty of the cosmos. Multiverse theories propose the existence of multiple universes beyond our own, each with its own set of physical laws and constants. These theories have gained popularity in both scientific and philosophical circles, offering potential explanations for some of the most puzzling questions in physics. One of the most well-known multiverse theories is the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of a quantum event actually occurs in a separate universe. This idea challenges our traditional understanding of reality, suggesting that the universe is constantly branching into countless parallel worlds. Another intriguing concept is the bubble multiverse theory, which posits that our universe is just one of many bubble-like regions in a larger multiverse ocean. These bubbles may collide or even spawn new universes, each with its own unique properties. The string theory landscape takes a different approach, proposing that there are an enormous number of possible universes, each with its own configuration of strings and dimensions. This theory suggests that our universe is just one of many possible solutions to the equations of string theory. The concept of a parallel universe, on the other hand, suggests the existence of universes that are similar to our own, but with slight variations. These variations could range from minor differences in physical constants to entirely different histories and civilizations. The concept of a parallel universe, on the other hand, suggests the existence of universes that are similar to our own, but with slight variations. These variations could range from minor differences in physical constants to entirely different histories and civilizations. While these theories may seem far-fetched, they are rooted in the fundamental principles of physics and mathematics. They offer new perspectives on the nature of reality and the possibility of other worlds beyond our own. As scientists continue to explore these ideas, we may gain a deeper understanding of the universe and our place within it. Parallel worlds in physics is a fascinating concept that has captured the imagination of scientists and philosophers alike. In the realm of theoretical physics, the idea of parallel worlds suggests the existence of multiple universes that coexist alongside our own. These parallel worlds may have different physical laws, constants, and even dimensions, leading to a vast and diverse multiverse. The concept of parallel worlds is not a new one, with roots in ancient philosophy and science fiction. However, in recent years, advancements in quantum mechanics and cosmology have brought this idea into the realm of serious scientific inquiry. One of the most well-known theories that supports the existence of parallel worlds is the many worlds interpretation of quantum mechanics proposed by Hugh Everett III in the 1950s. According to this interpretation, every quantum event results in the creation of multiple parallel universes, each branching off to accommodate all possible outcomes. This theory has profound implications for our understanding of reality and the nature of existence. Another theory that explores the concept of parallel worlds is the multiverse theory, which posits the existence of an infinite number of universes, each with its own set of physical laws and constants. These universes may exist in separate dimensions or even overlap with our own, creating a complex and interconnected web of realities. The study of parallel worlds raises important questions about the nature of consciousness, free will, and the fundamental structure of the universe. It challenges our traditional notions of reality and opens up new possibilities for understanding the cosmos. While the existence of parallel worlds remains a topic of debate and speculation, the exploration of this concept has led to groundbreaking discoveries in physics and philosophy. By considering the implications of parallel worlds, we are forced to confront the limitations of our current understanding and to imagine new possibilities for the nature of reality. The concept of the multiverse has profound philosophical implications that challenge our understanding of reality and existence. One of the key questions that arises is the issue of identity. If there are multiple versions of ourselves in parallel universes, what does it mean to be me in this particular universe? This raises questions about free will, determinism, and the nature of consciousness. Are our choices predetermined, or do we have the ability to shape our own destinies across different universes? The multiverse also challenges traditional notions of morality and ethics. If there are infinite versions of ourselves making different choices, how do we judge the actions of others when they may have taken a different path in a different universe? Furthermore, the existence of a multiverse raises questions about the nature of reality itself. What is the true nature of existence if there are countless variations of reality coexisting simultaneously? These philosophical implications force us to reconsider our place in the universe and the very nature of our reality. As scientists, it is important to not only explore the scientific aspects of the multiverse, but also to engage with the profound philosophical questions that it raises. Quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, has led to some fascinating theories about the nature of reality. One of the most intriguing concepts to emerge from quantum mechanics is the idea of the multiverse. According to this theory, there are an infinite number of parallel universes that exist alongside our own, each with its own set of physical laws and constants. This idea challenges our traditional understanding of the universe as a single, coherent entity and opens up a world of possibilities for how we perceive reality. In the multiverse, every possible outcome of every event is realized in a separate universe, leading to an infinite number of variations on our own reality. This concept has profound implications for our understanding of the universe and our place within it. The multiverse theory is not without its critics. However, some scientists argue that it is a purely speculative idea with no empirical evidence to support it. Others believe that the concept of the multiverse is a natural extension of the principles of quantum mechanics and provides a more complete picture of the universe. Regardless of where one stands on the issue, the idea of the multiverse forces us to confront the limitations of our current understanding of reality and consider the possibility of a universe that is far more complex and mysterious than we ever imagined. As we continue to explore the implications of quantum mechanics and the multiverse, we are faced with profound questions about the nature of existence, the limits of human knowledge, and the very fabric of reality itself. The multiverse theory challenges us to think beyond the confines of our own universe and consider the vast array of possibilities that may exist beyond our current understanding. It is a concept that pushes the boundaries of our imagination and invites us to explore the mysteries of the cosmos in ways that were once thought impossible. String theory is a theoretical framework in physics that aims to explain the fundamental nature of particles and forces in the universe. One of the key concepts in string theory is the idea that the most basic building blocks of the universe are not point-like particles, but rather tiny, vibrating strings. These strings can vibrate at different frequencies, giving rise to different particles with varying properties. String theory also suggests the existence of extra dimensions beyond the familiar 3 spatial dimensions and 1 time dimension. These extra dimensions are compactified and not directly observable in our everyday experience. The implications of string theory are profound, potentially providing a unified description of all fundamental forces in nature. One of the intriguing aspects of string theory is the possibility of a multiverse. The multiverse hypothesis suggests that our universe is just one of many universes that exist simultaneously. Each universe in the multiverse could have different physical laws, constants, and properties. This idea arises from the mathematical consistency of string theory, which allows for a vast landscape of possible universes. The concept of the multiverse raises profound questions about the nature of reality, the existence of parallel worlds, and the role of consciousness in shaping our experience of the universe. The multiverse hypothesis is not without controversy, as it challenges traditional notions of scientific inquiry and empirical verification. However, recent developments in cosmology and theoretical physics have provided some support for the idea of a multiverse. The search for evidence of parallel worlds and alternative realities continues to be a topic of active research and debate among scientists and philosophers. As we delve deeper into the mysteries of string theory and the multiverse, we are confronted with profound questions about the nature of existence, the limits of human knowledge, and the ultimate structure of reality. One of the main criticisms of multiverse theories is the lack of empirical evidence. Since we cannot directly observe or test other universes, some argue that these theories fall outside the realm of science. Without the ability to confirm or falsify the existence of parallel worlds, critics question the validity of such speculative ideas. Additionally, the sheer complexity and diversity of multiverse models can be seen as a weakness. With so many different variations and interpretations, it becomes challenging to determine which, if any, of these theories accurately describe reality. Another point of contention is the issue of Occam's razor, a principle in philosophy that states the simplest explanation is usually the best. Critics argue that invoking an infinite number of universes to explain phenomena may be unnecessarily complex and therefore less preferable than simpler explanations. Furthermore, some critics raise concerns about the philosophical implications of multiverse theories. By positing the existence of countless parallel worlds, these theories challenge traditional notions of uniqueness and significance. This can lead to questions about the nature of identity, consciousness, and free will. Overall, while multiverse theories offer intriguing possibilities for understanding the cosmos, they also face significant criticism from both scientific and philosophical perspectives. In conclusion, the concept of the multiverse and theories of parallel worlds have opened up new avenues for exploration in both scientific and philosophical realms. The idea of multiple universes existing simultaneously, each with its own set of physical laws and constants, challenges our traditional understanding of reality. Through the study of quantum mechanics, string theory, and cosmology, scientists have proposed various models of the multiverse, each with its own implications for the nature of existence. Philosophers have also grappled with the implications of a multiverse on concepts such as free will, determinism, and the nature of consciousness. As we continue to delve deeper into these theories, it is clear that there is still much to be discovered and understood. Future research directions in this field could involve further exploration of the mathematical frameworks that underpin multiverse theories, as well as experimental tests that could provide empirical evidence for the existence of parallel worlds. Additionally, interdisciplinary collaborations between physicists, philosophers, and other scholars could help to shed light on the profound implications of the multiverse for our understanding of the universe and our place within it. By continuing to push the boundaries of our knowledge and imagination, we may one day unlock the secrets of the multiverse and gain a deeper insight into the fundamental nature of reality.